Important terms and their definitions. Feature-based modeling. A feature is the smallest part of an object. A feature is the building blocks of an object. So we can modify these features. In this particular case, this feature here is a hole. And you can see over here in my browser, I have a hole feature. And so parametric modeling. Parametric modeling means we can give it a new size and shape based on our geometry. So I can just click on some of these things and I can edit the hole, and I can pick new geometry all I want, and I can choose different styles of the hole features. Bi-Directional Association. When we make a drawing of this, a multi-view drawing, or say a section view of this, that when we change it in the drawing, we can change this 3D model. So adaptive. Adaptive is when we can make a small change to something in its shape and size, but yet we don't have to make numerous of those particular parts. So this reduces our time and effort to create very similar parts. So we only have to make one item of a pin, and we can have many different sizes pins, and if we need to. The design doctor. The design doctor is a feature in which we can select a particular model. Here's a model here, and we can select it. We can examine it for errors. And then if we get an error, it'll provide some solutions of how to fix those particular errors. Constraints. Constraints in Inventor, we have geometric constraints. And geometric constraints are constraints based on its geometry, and we have 4 different geometry ones. One is perpendicular, one is concentric, one is collinearity, and one is parallel. So these are based on parallels, based on its geometrics. So we can say one surface is going to be parallel to another, or one surface is going to be perpendicular to another. And so when we draw our sketches, we can say, yes, we want this surface, this line to be perpendicular or parallel to the others. We also have horizontal constraints and vertical constraints. We can say 2 holes are equal to each other in its constraints. So when we change one, it changes the other. So we can say it's symmetric above a particular edge. We can have 2 holes symmetrical. We can have something fixed. All these are based on its geometry. So that's why they're called geometric constraints. Assembly constraints. When we have an assembly of a variety of parts put together, we can constrain those parts. We can mate 2 items together on, say, a surface. These 2 parts are mated or placed together. We could put an angle constraint to place 2 faces on a particular angle. We can place them tangent to each other. We can insert one into another. We could place something that's circular into another one that can fit into that. Symmetry, we can place 2 components so they're symmetrical above each other. We also have assembly joints. Now joints they allow motion between 2 connected components in assembly. So we have these different styles of joints. We have an automatic, which Inventor automatically determines the style of joint. We have a rigid joint, which removes all its degrees of freedom. So it's really 2 parts kind of fixed rigidly together, and it can't move. We have rotational, so it spins. We have a slider that goes back and forth. It goes up and down on a particular path. We have a cylindrical, which allows it to go around an axis of a cylinder. We have planar, which means it can go on 2 different, like on a sheet of paper, it can go in 2 different directions, up and down, left and right type of thing. And we have a ball joint. And a ball joint means that we can create a ball and things will rotate freely around that ball, and and so the two remain in touch with each other, but they are restricted at a common point. We have a motion constraint. So when we have motions, we have a rotational motion and we have a rotation translation. So a translation is when we're moving in an XY direction, and rotation is when we're spinning around an axis. We can limit motion to be either constrained to the motion of the constraint in rotational or in transitional. And we also have what's called a consumed sketch. When we draw a 2D sketch and we make an outline in 2D, when that is utilized in things such as revolve or extrude or sweep or loft, that sketch gets consumed or eaten up by it, so we no longer have that sketch. So we have a variety of terms that we'll use throughout our learning of Inventor, and these we'll come back to each one of these and visit each one of these important types of terms and their definitions later.